Why does Bill Gates have so much money? Because he earned more money than he spent. Why did basketball team X win the big game? Because they scored more points than team Y.
God damn it, Pete. Why are you fat?
The typical answer is that more calories went in than out of Pete's body. The responses to these four questions aren't technically wrong, but they're not helpful. Calorie counting may induce weight loss, but why would you care about that? Losing 10 pounds is great, but wouldn't you want to know where that 10 pounds came from? Was it bone, muscle, or fat? Then if it's fat, which is what most of us would want to lose, is it subcutaneous fat or visceral fat? Pediatric endocrinologist Robert Lustig points out in his book Fat Chance that several studies show that the amount of subcutaneous fat you have, the fat under your skin, correlates with increased longevity. Whereas visceral fat, the fat around your organs that gives you a big belly, promotes inflammation and causes several health detriments, meaning the difference between dying early in your 50s or living into your 80s or longer. A pound of fat being 3,500 calories is usually the piece of data we're provided with to help us create our weight loss goals. For example, if you create a deficit of 500 calories per day, then in a week you will lose a pound of fat. But why would the body choose to discard fat first when you restrict calories? Decreasing your energy intake is interpreted by your body as you being in a situation where less energy, food, is available. Thus, it will do what it can to keep the stored energy it has and slow down processes that spend energy. Muscle is a relatively energy expensive tissue, while one of fat's functions is to serve as a place for energy storage. So the body would want to preserve the fat and break down the muscle to conserve as much energy as it can. And that's what it does. Through a process called gluconeogenesis, new glucose making, muscle is broken down into glucose, which can be used for energy. So now you have successfully reduced your weight by going into a caloric deficit. But now it's even harder to create a caloric deficit and lose more weight because your resting energy expenditure is now less due to having lost muscle. Jonathan Baylor points out in his book The Calorie Myth that studies show that up to 70% of the non-water weight lost when people are eating less comes from burning muscle, not body fat. Only after it's cannibalized this muscle will our body burn fat. So your calorie restrictive diet may actually reduce your weight as you intended, but the weight isn't necessarily coming off from where you'd like it to, and this whole process becomes an uphill battle. Restricting calories without modifying the composition of your diet will cause your body to lower energy expenditure and increase hunger to provoke you to get back to your normal energy intake. Eat less and exercise. The typical advice for weight loss is a strategy fueled mainly by willpower. Hunger and lowered energy expenditure is going to set you up to where the last thing your body wants to do is exercise. Alright, maybe it's more simple to look at how people get too fat in the first place. Surely to get fat, one has to eat too much. But what causes that excessive eating? We have very sensitive receptors in our body that let us know when it is too hot, too cold, when we're thirsty, etc. What would cause someone to eat past the point of satiety so much and so frequently that they become overweight or obese? Of course, small fluctuations in weight throughout the year is not unnatural, but when people get significantly overweight or obese over time through overeating, surely something is significantly wrong with the way their body processes food and the way their hunger and satiety receptors work. So what calories in, calories out isn't explaining is why some people's bodies will just raise energy expenditure in response to eating too much, keeping them thin while other people get fat. Just because you eat extra calories doesn't mean that they have to be stored. They could just be burned off automatically. The medical journal QJM reports, food in excess of immediate requirements can easily be disposed of, being burnt up and dissipated as heat. Did this capacity not exist, obesity would be almost universal. So why is it that obese people don't automatically dispose of calories, experience intense lethargy, and have voracious appetites, despite having massive amounts of energy available in the form of fat on their body? What is particularly interesting about this is that the satiety hormone, leptin, is secreted by your fat cells. So if we are to assume that a calorie is a calorie and the type of food you eat does not have any peripheral effects, like disrupting the hormonal environment of the body, then fat people should have less of an appetite than leaner people. We would need to assume that all overweight people have something like a gene defect that screws up their hormones, leading to this dysfunctional situation where the brain is constantly being told to eat more food despite having plenty of stored energy available on the body. Robert Lustig explains that only 2% of morbid obesity is explained by genes. Researchers worldwide have scanned the human genome and have identified 32 genes that are associated with obesity in the general population. Altogether, these genes explain a total of 9% of obesity. And even if one person had every single bad gene variation, it would account for only 22 pounds, hardly enough to explain our current obesity pandemic. So when people get fat, they are, of course, for some reason or another, taking in more calories than they need to. But their body, for some reason, chooses to use nearly all of these extra calories for body fat accumulation, even at the expense of muscle.
And I always had it in my head that the morbidly obese were probably pretty well muscled underneath all that because effectively they're lifting weights all the time. But it's not the case. Their muscles are extraordinarily atrophied. Your external oblique muscle that ought to be about, as thick as a piece of steak, in these people is paper thin and stretched to the point of bursting because they are having nutrient partitioning that doesn't allow any energy to go anywhere but to body fat. So they are literally starving inside an encasement of blubber.
A good example for understanding why the body uses calories in different ways is puberty. During puberty, young men and women develop bigger appetites, and that extra energy is put towards developing things like sex organs and making the body larger in general. But young men put on a lot of muscle during this phase, whereas young women put on more fat. You might attribute this to the fact that young men are more likely to play sports, but the way the fat is distributed is very different between the two genders. Most guys are not going to find that their pants are getting tighter due to butt and hip fat. This is the effect of several hormones, particularly one named insulin. Insulin is an anabolic hormone. It's known as the energy storage hormone or sometimes the fat storage hormone. One of its jobs is directing how the food you take in will be stored, and puberty is associated with a higher than normal secretion of insulin. A very clear illustration of insulin's fat accumulation abilities is the side effects some diabetes patients experience where they develop a mound of fat at the site where they frequently inject their insulin. This is called lipohypertrophy. So, understanding how food affects hormones would be better for weight management than understanding how many calories are going in and out of your body. Other than insulin, worthwhile hormones to look at are leptin and hormone-sensitive lipase. Leptin is the satiety hormone. If you have higher leptin levels and your brain has no problem reading these levels, then you feel full. And hormone-sensitive lipase breaks down fat so it can be used for energy. This, of course, is important if you want to lose body fat. Researchers at the Veteran Affairs Palo Alto healthcare system genetically altered mice so they could no longer make use of hormone-sensitive lipase. These mice ate more and gained 70% less than normal mice. Completely independent of calories, altering the mice's hormones caused a drastic reduction in body fat accumulation. So the ideal situation is to have high levels of leptin so you are not hungry all the time, and you would want to lower levels of insulin so your body doesn't store too much energy, and you would want hormone-sensitive lipase to be activated so it would break down body fat. Losing body fat while not being hungry would be the ideal situation. The problem with calories in, calories out is it doesn't tell you anything about how to achieve this preferred hormonal situation. But paying attention to how much of and what kinds of proteins, fats, and carbohydrates are in your meals will tell you much more about how your hormones are going to respond. This brings us to the next point. Is a calorie a calorie? For a calorie to be a calorie, we would expect all foods to be processed in similar ways in the body without having unique effects on our hormones or other biochemical processes. But in the case of alcohol, a calorie is clearly not a calorie, as it has some interesting peripheral effects due to the fact that 10% of the alcohol you ingest is metabolized in the brain, making you drunk, and 80% of it is metabolized in the liver, leading to liver disease and other problems. Another one is trans fats, which are very different from other fats. The synthetic nature of trans fats doesn't allow them to be broken down in your mitochondria, and they contribute to metabolic disease and atherosclerosis. Proteins get broken down into amino acids in the body, and the liver will use these for either protein synthesis, i.e. muscle growth, or convert them into glucose or fatty acids. These processes, though, depend on your insulin levels, whether you have broken down your muscle tissue through exercise, and how much glucose is stored in the form of glycogen in your body. And there are all kinds of amino acids, some that are essential and can only come from the diet, and some that are non-essential. Fats, on the other hand, get broken down into free fatty acids, and they will be processed by your mitochondria for energy, or stored in the muscle, or stored in your fat tissue. And there are several different types of fat, some good, some bad. For example, you have bad ones like trans fats we just talked about, and you have fatty acids like DHA, which is theorized to be what allowed humans to evolve their big brains. Glucose, the carbohydrate found in things like rice or vegetables, passes into the bloodstream and then stimulates the pancreas to make insulin, allowing it to get into the cell so that it can be burned up for energy, or it may be stored as glycogen. Depending on how much glycogen is already stored in the body, and how quickly and how much glucose is entering your system at one time, glucose may be stored as fat through a process called de novo lipogenesis. Keep in mind that the fiber in vegetables is going to slow down the rate at which glucose is processed. So your body will react very differently to, say, 50 grams of glucose from white bread and 50 grams of glucose from broccoli. Now, there's another carbohydrate called fructose or fructose found in sweet things like fruit, juice, honey, or table sugar. The tricky thing about table sugar, or sucrose, is it's comprised of one molecule of glucose and one molecule of fructose. Yet glucose by itself is sometimes called sugar. For example, blood sugar is synonymous with blood glucose. However, what I'm discussing is fructose, a molecule very different and much sweeter than glucose. Fructose is technically a carbohydrate, but it is not necessary for any biochemical reaction in the body, so almost all of it is processed in the liver. The interesting thing about fructose is, among other negative effects like promoting the development of fatty liver disease, is it causes insulin resistance, meaning the more you eat sweet things, the more your pancreas will have to secrete insulin to get its job done, leading to higher and higher insulin levels. Fructose, by the way, is in 74% of all packaged foods in the market, in the form of added sugars. If you're trying to lose body fat, you'll want to keep an eye on insulin. When you have high levels of insulin, hormone-sensitive lipase, which breaks down fat for energy, is much less active. In this case, if you haven't eaten for a couple hours, you start to get really hungry because you can't actually use any of that fat on your body for energy. So your body fat continues to stick around and you feel pretty crappy. Another reason behind the hunger is that high levels of insulin block your brain from seeing the leptin signal. You become resistant to leptin. Leptin, again, is the satiety hormone. This is how eating too many things like packaged foods or refined carbohydrates that spike insulin levels can cause people to be hungry and lethargic despite having so much energy stored on their body as fat. So yes, Pete is fat because he ate too much, clearly.
I'm not fat.
But the reason he ate too much has to do with his hormones. A calorie is a calorie in the way a gram of money is a gram of money. A kilogram of $100 bills is going to affect your bank account much differently than a kilogram of 1 yen Japanese coins. For some people, calories have worked as a decent rule of thumb for them. But tracking the macronutrient composition of your food is going to give you much more insight into how your food is affecting your body than just calories. There's still a lot more to be said about macronutrients, but you can notice their effects pretty quickly if you pay attention. Does a breakfast high in fructose and glucose like orange juice and a big bowl of cereal with flavored yogurt leave you feeling hungry and tired by the time you get to work? And does a meal high in good fat, protein, and fiber like salmon, eggs, and vegetables make you feel any different?